All right, this is just a video recording of an answer key that I've created for physics, extra practice for vectors and projectile motion. So we have a dart launched at a dartboard, and we want to determine if it hits the dartboard. Okay, so we know the x direction velocity, 3.5. We know it's constant velocity. So we know the displacement that it goes through. So I say s equals vt. So 2.5 equals 3.5 t. Time is 0.714 seconds. Then I just have to plug that into the y equation, remembering that y velocity initially is 0. And then we use 1/2 at squared equation. And notice how I have a plus 2.8 beginning height, because I got to figure out the height when it reaches the target. And it's 0.3 meters, so therefore it does hit it. Now when I want to determine a velocity vector when it hits the target, I just need to find the velocity in the y direction at 0.714 seconds. And then I Pythagorize that together and inverse tangentize that. So I've got an x direction velocity and a y direction velocity. Ending result is 7.82 meters per second at 63.4 degrees below the horizontal. All right, next question. I've got a fireman putting out a fire. We have a beginning velocity of the water. Okay, and we're going to pretend it takes a perfect parabola to there and there's no air resistance. The water is launched at an angle theta. Okay, the distance is 50 meters away from the burning building. He directs a stream of water from the ground at 30 degrees above the horizontal. If the speed of the stream that leaves the hose is 40 meters per second, at what height will the stream of water strike the building? Well, we know the definite displacement in the x direction is 50. So then I have, I'm going to do 40 cosine 30 to get my velocity in the x direction, 34.6. And I'll likewise do the sine to get the velocity in the y direction at 20.0. So since I know my x direction displacement, I'm just going to go 50 equals 34.6 t. That's my time. I will plug that into the s equals v1t plus 1/2 at squared equation in order to get a height of 18.7 meters. And notice how I'm putting in vx and vy. I'm not using the hypotenuse value. All right, next question. So we have Evie launching a water balloon at Tommy, who thinks he's safe by hiding behind a wall. Okay, determine the minimum launch angle needed for the balloon to make it over the wall. Okay, well, here goes. So I did Vx is 12 cosine theta, Vy is 12 sine theta. Well, I know at max height, my velocity in the y direction will be 0, and that's what I'm talking about here. So when this balloon reaches here, the minimum would be we're at max height there. So my beginning velocity v naught sine theta, v final is 0, my acceleration negative 9.8, time is a question mark, displacement is 3. It's got to be at least a height of 3 when it reaches there. So then I go 0 squared equals my velocity y squared initial plus 2a times 3. Since I have sine theta in here, I just solve for theta, and theta is 39.7 degrees. I would need to take inverse sine. Then it says, at what distance from the wall will Tommy get hit if the balloon just makes it over the wall? Well, at the max height here, velocity in the y direction is 0. So I'm just going to take this from this point. I'm going to pretend that we just launched this balloon right from the top here, and we're going to see where it hits him. So that's why v initial is 0, v final is a question mark, my acceleration, of course. My displacement is 3 minus 1.9, which is a negative 1.1. I made that negative because if you look at the beginning here, the balloon, of course, is 1.1 above Tommy's head. So I'm thinking a negative 1.1 downwards gets Tommy in the head at least. So there you go. So then I find the time it takes to reach a height of, or to go negative 1.1 meters downwards, and that's 0.473 seconds. And then I just use s equals v in the x direction times t to find out where Tommy needs to get hit in the head, okay, with this water balloon. Next, our last question here. We have a basketball and it's on a truck, but the truck is moving to the right at 14.4 meters per second. And of course, we kick the ball or move the ball 5.6 meters per second across. So once again, I get my Vx and I get my Vy. Determine the time it takes for the ball to roll across the width of the truck. Well, I know it's 8 meters in the y direction. So I'm going to choose the y velocity in s equals vt. I find the time is 2.62 seconds. How far in the east direction relative to the ground? Okay, will the ball move while it was going across this direction here. So now I have to remember that my Vx is the 4.7, but remember we're also going 14.4 meters per second that way. So then I take and add those two together. Now my x direction velocity is 19.1, moving this way, because it's got an x direction velocity initially because it's been rolled, but it's also moving to the east direction, so I got to add those two together. So I'm just going to use s equals vt to find 50 meters. And then lastly, determine the velocity of the ball relative to the ground. Okay, that's just a vector addition. I's and j's. The 14.4 comes from the truck moving. 4.7 is my I for the ball moving on the truck, and likewise the 3.05 is the j. I add my i's and j's together, and I Pythagorize and inverse tangentize together to get 19.3 meters per second at 9.07 degrees north of east. And that's how we do all those.